Hello guys, this is Scholastic Sam coming back at you guys with another video. Today in our unit, or today in topic C of other parent functions and other function characteristics, we are going to be talking about even and odd functions. So characteristics, there are three options. Normally, so they're going to say, is it even, odd, or neither? So you have to tell, is it odd? Nope. Is it even? Nope, it's neither, unless it's either even or odd, in which you would write that. So let's see, how do we find out from the graph and equation whether it's even or odd? Well, some characteristics of odd functions are it's symmetrical with respect to the point of origin, meaning if you reflected it over the point of origin, you get the same thing. Opposite end behaviors, as x approaches negative infinity, it does something different than as x approaches positive infinity. For example, if the left side's going down and the right side's going up, then that would not be even. That would probably be odd. Well, it would be odd. And if it's going up on the left side and down on the right side, that would also be odd. Now, it's called an odd function because the highest power is odd. For example, if you have x cubed minus x squared, the highest power is 3, which is odd. Now, if we use this and look at the equation, we get f of negative x equals negative f of x. The best way to think about this is that the opposite input gives the opposite output. Input is x, of course, and output... Shoot, my bad, guys. I just hit that. I'm clumsy. And it gives the opposite output, and the output is y. Now let's do a practice problem. So if we take this practice problem, let's look at the equation first. Y equals 2x cubed. Well, right off the bat, we know it's odd because x cubed is 3 is an odd number. But let's check using our formulas. So let's say x is 2. Well, we know that f of negative x equals negative f of x. So if x is 2, that's going to be the same as f of negative 2. Negative 2 cubed is just negative 8 times 2 is negative 16. Now let's try negative f of x. This should be negative 16 also because they have to equal each other. Well, if x is 2, then 2 cubed is 8 times 2 is 16. Now, negative f of 2 is the same as negative 16. Now, let's look at the graph. We see that it's going down here and up here. Well, those are opposite actions. As x approaches negative infinity, f of x approaches negative infinity. As x approaches positive infinity, f of x does not approach negative infinity. It goes up and approaches positive infinity. I also see that if we reflected it off the point of origin right here, which is 0.00, where the y and x-axis intersect, we would get the same thing. This here is pretty much just the opposite of that there. So yeah, the graph checks out. Also, the midpoint there of the graph is on the point of origin. The graph checks out and the equation checks out, so we know this one must be odd. Let's look at even functions. The highest power is, of course, an even number. The end behavior is the same on both sides, either up or down. So if it's going up and up or down and down. F of x equals f of negative x. That means that if you put in an x value and you put in the opposite of that x value, the y value is going to be the same. That's because if you do any number to an even power, it's just going to automatically make it positive. So negative 3 squared is 9, and 3 squared is also 9. And it's symmetrical with respect to the y-axis. Also, the vertex is going to be on the y-axis. Now, this means that the left side, the y values on the left side are going to be the same as the y values on the right side. So if you hold, I don't know if you guys have something that like reflects and you put it in the vertical line on the y-axis, it'll be the same here as it is here. So I'm trying to reflect with my hand. It'll be the same here as there. Now let's do a practice problem. X squared minus 2. We see right off the bat, 2 is an even number. Let's try with the equation. If x is 3, well, f of x, that would just be 3 squared is 9, minus 2 is 7, or f of negative x. So we do the negative 3 squared is 9, minus 2 is also 7. Now let's look at the graph. We see the vertex is on the y-axis. seems that the y values on this side are the same as on that side. It looks to be like you can reflect it across the y-axis. If this side was flipped over, the graph would be the same as there. And if you flip both sides over, it would be the same graph. And also, as x approaches negative infinity, y approaches positive infinity. And as x approaches positive infinity, y also approaches positive infinity. So on the left and right sides, they're both going up. They're both approaching positive infinity. If it was odd, one would be approaching positive infinity, and the other would be approaching negative infinity. So yeah, this looks like an even function. The graph also shows that. So this must be an even function. Now, as we talked about, let's say we did x minus 1 quantity squared minus 2, and this was shifted 1 to the right. Well, it wouldn't be, if you reflected over the y-axis, that wouldn't work. It would be a different function. Also, the vertex wouldn't be on the y-axis. So for that one, if that happened, you would write neither. Okay, thank you guys. I hope you now understand the concept and how to identify even and odd functions. If you have any questions, comments, or concerns, please leave them in the comment section below. Please like, share, or please like, subscribe, and turn on post notifications. Shout out to Mr. Barrett. Thank you guys. I'll see you next time. Bye. Also, I take video requests.